Hello students, welcome to Learner's Planet. This is our last theory session for the topic structure of the atom. In this session we are going to discuss about the isotopes and the isobars. So let's start our session. What are isotopes? Isotopes are atoms of the same element having the same atomic number but different mass numbers, right? That is, they are having the same number of protons but different number of neutrons. What is the atomic number? It is the number of protons in an atom. And what is the mass number? Mass number is the sum of number of protons and neutrons in an atom. So the isotopes have got same number of protons but different number of neutrons. That is why their mass number is different. Isotopes of an element have the same atomic number because they contain the same number of protons and therefore the electrons, because the number of protons is equal to the number of electrons in a neutral atom, but different number of neutrons in their nuclei. Let's take a few examples. All the chlorine atoms contain 17 protons. So the atomic number of all the chlorine is 17. Chlorine atoms. Some chlorine atoms have 18 neutrons, whereas other chlorine atoms have 20 neutrons. So what will be the mass number of chlorine atoms? 17 plus 18, that is 35, and 17 plus 20, that is 37. Thus, chlorine has got two isotopes with mass numbers 35 and 37. It is written as Cl1735 and Cl1737. If I am taking chlorine gas in a tube, it will be a mixture of Cl35 and Cl37. So there are many elements, students, like hydrogen, which exist as the mixture of different isotopes. Hydrogen, the proton, the protonium, it has got one proton, one electron, or one one proton only. It doesn't have neutron. Deuterium has got one proton and one neutron. And tritium has one proton and two neutrons. Hydrogen has got only one proton. So the atomic number and mass number is 1. Whereas in case of deuterium, the atomic number is 1, whereas the mass number is 2. In case of tritium, the atomic number is 1 and the mass number is 3. Now in the hydrogen gas there are 3 isotopes present. Likewise, there are many elements which are the mixture of these isotopes. And there are elements also which do not have any isotope. Right? If an element exists in isotopic forms, then the mass of atom of element is calculated as average mass of all the naturally occurring isotopes. If an element does not have any isotope, then the mass number is the sum of proton and the neutrons. The sum of the numbers of protons and the neutrons. Now let's see how the mass of chlorine is calculated. The average mass of atom of an element which has different isotopes is calculated by taking percentage occurrence into consideration. See, the percentage occurrence of Cl35 isotope is 75, whereas of Cl37 is 25. So the average atomic mass of chlorine is calculated like this. 35 multiplied by, it will be 0.75 plus 37 multiplied by 0.25, and it will give the average atomic mass of chlorine atom. That is 35.5 units. Now, does it mean that one of the chlorine atom is half? It's 35.5. It doesn't mean that one chlorine atom is half. It's if I'm taking chlorine, then it will contain both the isotopes of chlorine. That is why the average mass is coming out to be 35.5 units. These are examples of isotopes. Isotopes of hydrogen. This is prosium, deuterium and tritium. Isotopes of carbon. Carbon-12 and carbon-14. How will be the average mass of this carbon calculated? Average mass number or atomic mass of carbon atom calculated by taking the percentage occurrence of carbon-12 and carbon-14 into consideration. That is the mass number multiplied by, I'll write it here. It is the mass number of an isotope. Mass number of an isotope multiplied by the percentage occurrence of that isotope plus the mass number of second isotope multiplied by the percentage occurrence of second isotope. Likewise, the isotopes of oxygen are there, O16, 17 and 18. So there are many elements which exist in different isotopic forms. Let's see the properties of isotopes. All the isotopes of an element have identical chemical properties. They have identical chemical properties because they have got same number of protons. That is, proton in one isotope is equal to the number of protons in the second isotope. If the number of protons are same, the number of electrons will be also same. What is the entity in an atom which takes part in the chemical reaction? It is electron. Valence electrons takes part in the reaction forming the compound. Now isotopes, they have got same number of electrons, so they have got similar chemical properties. But the physical properties, see, the physical properties of the isotopes of an element are different. Because the neutron, isotopes have got the different number of neutrons. And neutrons are the heaviest particle among the protons and the electrons. And neutrons, right? Of all the three subatomic particles, which are the heaviest ones? The neutrons. So the masses of all the isotopes of an element are slightly different. Now, as they have got different masses, their other physical properties like their boiling points, their melting points, their density, they are all different. They show similar reactions, but the rate of reaction differs. They'll definitely show similar reactions because they have got same number of electrons. But the rates of reaction are different. So understood this? The chemical property of an element depends upon the number of electrons present in the atom of that element. As the number of protons and electrons are similar or equal in the isotopes, they have got similar or identical chemical properties, whereas their physical properties are different, as their masses are different. Why their mass is different? Because of the number of neutrons. There are many elements which existed as isotopes. Likewise, there are radioisotopes also, that is, which emit radio waves, which emit the gamma rays or alpha rays, which go on emitting these radiations. Let's see the radioactive isotopes. The isotopes which are unstable and emit various types of radiations are called radioactive isotopes. What are these radiations? Radiations are the form of energy. What are these? These are the form or forms of energy. That is, energy is emitted in the form of radiation, right? It can be the alpha particles or the beta particles or gamma rays. These rays are emitted by unstable nuclei of radioactive isotopes. What are radioactive isotopes? The isotopes which emit various types of radiations, like carbon-14, arsenic-74, sodium-24, iodine-131, cobalt-60, uranium-235. So they emit various types of radiations. These isotopes have got wide applications, the radioactive isotopes. In medicine, they have got a wide application. Let's see what all applications do radioactive isotopes have in medicine. Applications of radioactive isotopes. Apart from medicine, these are also useful for generating electricity. Radioactive isotopes are used as a fuel in nuclear reactors of nuclear power plants for generating electricity. For example, U-235. It is an isotope which is used as fuel in the reactors of nuclear power plants for generating electricity. These are also used as tracers in medicine to detect the presence of tumors or blood clots in the body. Tracers, you understand? What is it? See, these isotopes, they emit radiations. If a small amount of it is given to the patient, that particular small amount can be detected throughout the body with the help of the radiation, wherever it will move with the blood flow. Say arsenic-74 tracer. A small amount of arsenic-74 is given to the patient, and this is tracked by the machine which can see the radiation, or which can tell us about the radiation, or which tracks the radiation. So wherever this arsenic-74 will go, it will track it. This arsenic-74 tracer is used to detect the presence of tumors. Likewise, sodium-24 tracer is used to detect the presence of blood clots. So if there are tumors or blood clots, these tracers will not enter that particular entity. The tumors, they'll not enter. They'll move with the blood throughout the body, but they'll not move through the tumors or the blood clots. They'll be stopped there. So these are used as tracers. Radioactive isotopes are used to determine the activity of thyroid gland, which helps in the treatment of diseases like goiter. What is radioactive isotope? Which radioactive isotope might be used here? It is It is iodine 131 radioisotope is used as a tracer to find how and at what rate thyroid gland in our body takes up iodine. And iodine is essential for making the hormone thyroxine. So this helps in the treatment of diseases like goiter. Likewise, cobalt-60 radioisotope is used to cure cancer. What happens? When the high energy gamma radiations emitted by cobalt-60 radioisotopes are directed at a cancerous tumor in the human body, the cancerous cells get burnt. So to burn the cancer cells, radiations emitted by cobalt-60 are used. Which radiations are emitted? These are the gamma radiations. Gamma radiations are emitted. The treatment of cancer by using radioactive radiations is called radiotherapy. Radioactives, so these are the uses of radioactive isotopes in medicine. There are many more uses. I have discussed a few of them. Radioactive isotopes are used in industries to detect leakage in the underground oil pipelines, gas pipelines, and water pipes. So it depends, students. This radioactive isotope has got wide application in the medicine, in industries for generating energy. Even these isotopes can be used for making bombs, for making atomic bombs. So it depends on human beings how to use this radioactive isotopes. It can be used in medicine, it can be used for problem solving, but not for creating problems. There are so many radioactive isotopes which can be used to solve our problems, which can be used to generate power, which can be used to generate electricity, but they should not be used for making bombs and all. As elements exist as isotopes, they do exist as isobars also. So let's discuss about the isobars. Isobars. Isobars are the atoms of different elements having different atomic numbers but the same mass number. So what are isobars? The atoms of different elements having different atomic numbers but the same mass number. They are of different elements. For example, argon 4018 and calcium 4020. They've got same mass numbers with different atomic numbers. Isobars have different number of protons in their nuclei, but the total number of nucleons in them is the same. Right? So these are the isobars. Example, argon 4018 and calcium 4020. This is all about this chapter, students, about the topic structure of the atom. You'll be studying them in more details in your higher grades. Thank you, students, for listening patiently. Then just go through the topic so that all the concepts are clear to you. Thank you and do have a nice time ahead.